3 years ago, NASA unveiled its next generation spacesuit designed to allow humans to walk on the moon. But after this, everything went quiet and the spacesuits were never seen again. It turned out NASA was 20 months behind schedule and millions of dollars over budget with the program. So, in order to get a new spacesuit developed in time for the upcoming Artemis mission, NASA set up a competition and invited other companies to design the best suit. At the time, SpaceX already had their own EVA suit, so you would think partnering with NASA to make an EVA suit would be the next step. But surprisingly, SpaceX didn't even put any bid for this contract. It turned out SpaceX had already been working on a EVA suit for years, and they wanted to go their own way with the development like they did with their first suit. In this video, we are going to learn how SpaceX mastered their spacesuit design and the key breakthroughs that made it possible. So stick around till the end of the video to find out how made it possible. SpaceX began developing their first spacesuit all the way back in 2015 when it hired Hollywood costume designer Jose Fernandez after several months of designing a suit that looked as sleek as possible. It was then up to the SpaceX engineers to reverse engineer it and make it functional. To be clear, this isn't the type of suit that an astronaut would wear outside on a spacewalk. This suit is primarily for keeping astronauts alive inside the spacecraft. But when you compare SpaceX suit to other spacer suits, it's look much sleeker. How is this possible? To answer this, we need to look at how spacesuits are normally designed. Spacesuits have traditionally been a one-size-fits-all type of things since they are very expensive to make. On the ISS, the EVA suit is modular, but in general, nothing is made to fit, and astronauts often get bruises and injuries after completing a spacewalk. This is where SpaceX excelled. Each suit they make is completely custom made to fit the shape of each crew member. This has the obvious benefit of creating a much tighter fit, but the benefits go much further than that. One of the biggest problems when it comes to designing a spacesuit is mobility. When the suit is pressurized, it inflates like a giant balloon, making it extremely rigid and stiff. When an astronaut tries to bend their joint, the overall volume of the suit is reduced. Since the suit is completely sealed, the air has nowhere to go, and so bending the joint compresses the air, creating a lot of resistance for the astronaut. Spacesuit designers over the years have come up with many different ways to tackle this problem. For larger joints like wrist and shoulders, mechanical bearings are used to allow movements without charging the volume. For smaller joints like the fingers, rubber plates are placed all the way down the back, forcing the glove to bend in an arc. This isn't very natural since our fingers don't bend like that. Depending on your shape, the joints in your suit may not align with the joints in your body. This could limit your range of motion and require more force to bend each joint. Since each SpaceX suit is tailor-made, these joints can be replaced with smaller ones that line up perfectly with the joints of each astronaut. But even with a custom-made suit, bending a seal tube full of air is very difficult. That's why every joint on the SpaceX suit is strengthened with these crisscross tensioners, which help the astronaut bend the joint inward. Then the pressure of the suit naturally helps the astronaut extend the joint back to its initial position. This is sort of similar to how a spider legs work. They only have a muscle to flex their limbs inward, and so they rely on hydraulic pressure stored inside their body to extend their limbs onward again. Another way to improve mobility is to simply have less air in the suit itself. The space shuttle suit operated at a pressure of 24 kilopascal, just a quarter of the pressure we experience here on Earth. Lowering the pressure may help with mobility, but it puts the astronaut at risk of getting decompression sickness. This is where the lower pressure inside the suit causes nitrogen in the body to dissolve and form bubbles in the blood vessels. Deep sea divers face the same problem when they come back up to the surface, as they quickly go from a high pressure environment to a much lower pressure environment. This can be a potentially fatal problem, and many spacesuits require the astronaut to do pre-breathing before suiting up. This involves breathing pure oxygen for several hours before wearing the spacesuit in order to get rid of all the nitrogen in the bloodstream. SpaceX didn't want to complicate the process, and so choosing a pressure for the suit was a constant fight between safety and mobility. SpaceX suit had to meet NASA's minimum requirements of 40 kilopascal to avoid decompression sickness. This is quite high compared to other spacesuits, so we can assume that SpaceX didn't go much higher than that. The air we breathe on Earth is a mixture of 21% oxygen and 78% nitrogen. But since the pressure inside the suit is lower, the astronauts wouldn't get a sufficient amount of oxygen. Some suits tackle this by making the air inside the suits pure oxygen. The SpaceX suits use a custom air mixture with a high percentage of oxygen that can be varied automatically by the onboard life support system. But it's how this pressure is managed that makes SpaceX suit even more impressive. Spacesuits typically have multiple valves and pipes on the outside to control the suit's pressure and temperature. SpaceX managed to combine all of this down into just one single port with a hole for air circulation, a power and communication connector, and a port to quickly inflate the suit during an emergency. An umbilical cord connects the suit directly into the astronaut seats. This is where the real magic happens. Here there are a series of solenoid valves that automatically control the pressure of the incoming air. A separate valve in the spacecraft allows chilled nitrox to flow into the suit's air dust, keeping the suit cool during re-entry. The pressure and temperature sensor inside the helmet feed the spacecraft with information, allowing it to automate the process. This level of automation took away the need for astronauts to manually adjust their suit pressure, allowing the designers to get rid of these bulky valves on the outside of the suit. Not only did this make the suit much lighter than the space shuttle suit, but it also made it much easier to put on. On the space shuttle suits, the helmet, gloves, and headset were all attached separately using bulky metal rings. On the SpaceX suit, the gloves and helmets are already attached, and the headset is integrated into the helmet. All of this means that an astronaut can suit up all by themselves in just a few minutes. The space shuttle suit, on the other hand, took more than 20 minutes and required help from several technicians. The SpaceX astronaut might not need any help in this department. To conclude, spacesuits are one of the most important pieces of equipment when it comes to space exploration. They protect the astronaut from pressure and temperature changes, provide oxygen, and keep themselves safe from radiation. SpaceX has mastered spacesuit in a way that is not only stylish but also practical. The company has designed their suit with a focus on engineering simplicity, comfort, and fit for purpose. Thank you very much for watching till the end, and I will see you in the next video.